Whether you have studied physics earlier or not, you would have definitely heard about black holes and they deserve it. In this video, I will tell you how you can make a black hole in the lab.
How much could I get a black hole for?
In practical ways, not just theoretical ones. Let's start from the basics. To understand the gravitational effect of any planet, we use the simple formula given by Newton, that is, G is equal to gm by r square. Keeping the mass same, if we reduce the radius of the planet, the gravitational effect starts increasing. If we keep reducing the radius further, at some point it approaches zero. So, if the denominator becomes almost zero, gravity approaches infinity. In this way, for every object, there exists a situation where it is compressed so much that even light would not be able to escape from it. And that critical radius is known as a Schwarzschild radius. Now, let me explain this with an example. The radius of the Earth is about 6,400 kilometers. And if we want to convert it into a black hole, we would have to compress it down to its Schwarzschild radius. You will be surprised to know if I tell you that Schwarzschild radius is just about 9 millimeters. I didn't stop here. Then I tried to calculate my own Schwarzschild radius and it came out to be around 10 to the power minus 24 meters. Then I calculated the Schwarzschild radius of an atom and it came out to be nearly 10 to the power minus 53 meters, which is even smaller than the Planck length, which is about 10 to the power minus 25 meters. Generally, it is believed that if we talk about length smaller than the Planck's length, the very idea of length starts losing its physical meaning. Now, to compress any object to this extent requires a huge amount of energy. Because of this, it is extremely difficult to create a black hole on Earth. But there are many objects in the universe whose mass is extremely large as compared to the internal pressure that tries to hold them up. The gravity plays the main role in compressing those huge stars and converting them into black holes. But wait, we can also do something similar. Though the method will be different, Einstein told us that mass and energy are equivalent. So, if we start moving an object close to the speed of light, its mass will begin to increase according to Einstein's equation. And that mass is fundamentally related to energy. Energy can be built, but after that it has to be collided with another particle. For that purpose, we already have Large Hadron Collider, but the problem is that in the LHC, around 10 tetra electron volts of energy is produced, and the corresponding Schwarzschild radius is about 10 to the power minus 50 meters. This means that this energy would have to be compressed into an extremely tiny region. But with current technology, we can only compress it into a region of about 10 to the power minus 20 meter, which is still very far from the actual Schwarzschild radius. But wait, there is one more way to make a black hole. For that, we would have to concentrate about 10 to the power 37 lasers into a region of about 10 nanometer. Just thinking about that makes it clear that it is not going to be possible in the next coming few years. But it's not impossible. Now imagine if we somehow manage to create a black hole, then what happens? Black holes are famous for pulling things inside them. But if we create very small black holes in a lab, they would behave in opposite way. They would throw energy out in form of Hawking radiation due to quantum effects, predicted by Stephen Hawking in the early 1970s. Think of it like this. If we create a 100 kg black hole, it would evaporate in just about a nanosecond, and the energy released from it would be so explosive that an entire city could be destroyed if it were not controlled. But we do have a possible solution. If we create a black hole with a mass of about 10 to the power 9 kg, its lifetime could be around 10 years. According to Stephen Hawking, its radiation could be controlled using reflecting mirrors, and then we could generate an enormous amount of power from it. So, the conclusion is, if our technology continues to improve, we may one day be able to build a black hole on Earth, or maybe even a wormhole, and at some point perhaps a time machine, which we will talk about in the upcoming videos. Thank you.